Welcome back. So we have learned about that how we can analyze an RLC circuit, okay, to find the energies for the energy storage elements for the inductor and capacitor in the last example. And previously we have learned that basically for the given waveforms, how we can basically get the desired, okay, up like current is given, how we can get the voltage and the vice versa. Now let's have a look about the concept of equivalent capacitance and inductance, okay. So far we have analyzed the cases with the single capacitors, okay, or even in the multiple capacitors in a simple circuit. So if we have a multiple capacitors, okay, which are connected in series, okay, like this one, okay. So basically, if you want to find the total net capacitance for this case, okay, so what we will do, we will simply basically we can replace this whole circuit, okay, with an equivalent capacitance like a one capacitance, just to make it our circuit simple. Okay, this is the same concept like we did in the earlier cases for the resistances. Okay, so simply if we are talking about the capacitor in series, let's say I have two capacitors in series and I want to calculate the net capacitance, so we will do the opposite of basically the resistors, okay, like we did. So in the resistor case, if the resistors are in series, we add them like R1 plus R2, okay, and if they were parallel, we use the parallel operation. So we will use the opposite here. If they are in series, like for example two capacitors are in series, so I will do 1 over C1 plus 1 over C2, okay, inverse, okay, like opposite of resistor. And if two capacitors are in basically parallel, so the net capacitance will be just like sum of those, okay, like we did in the series resistor. Okay, so in short, series capacitors will be calculated using the formula of parallel resistors approach. Okay, parallel capacitors, their net capacitance will be calculated using the formula, using the concept of series resistance of simple resistive circuits. So let's have a look at this circuit now. So a circuit is given, the question is determine the equivalent capacitance and the initial voltage. Okay, so let's first calculate the capacitance from this end, okay, equivalent capacitance. So if you look at this circuit, all these three capacitors are basically in series. So if they are in series, so we can write the equivalent capacitance as 1 over 2 micro plus 1 over 3 micro plus 1 over 6 micro, okay, and inverse of them, right? So if we simplify this one, okay, so our answer basically will be what? 6 over 6, okay, that will be basically 1 microfarad. Okay, so that will be the equivalent capacitance. So basically I can represent the whole circuit with one capacitors of 1 microfarad. Now the second question is, what is the initial voltage? Initial voltage means what is basically the voltage here. So for that, okay, we can do it directly, but just to make a simple steps, we can write the KVL here. Like what is the voltage drop here? Like minus V of t plus 2 volt, right? The voltage drop here is given. Voltage drop here for this capacitor is minus 4, okay. Then voltage drop across this capacitor is minus 1 is equal to 0, okay. So the total net voltage drop in a loop is 0, okay, in a circuit is 0. So basically initial voltage, it will be what? 2 minus 4, that will be minus 2, minus 2 minus 1, that will be minus 3 volt. So basically the drop here could be 3 volt. Okay, so this circuit can be simplified to this form. Thank you so much.